Namaste, I'm Shilpa. So this is the session related to the chapter atom. In this session I am going to discuss about the energy of a hydrogen atom. Energy of hydrogen atom. Here the total energy of a hydrogen atom. This energy means here it is a total energy is the kinetic energy plus potential energy of a hydrogen atom. By getting the kinetic energy and the potential energy, we can totally get the value for the total energy. Okay. So according to the Rutherford planetary model, we know that the nucleus will be at the atom. The nucleus of that atom will be at the center and the electron will be revolving around the nucleus. This nucleus is having the positive charge and the electron is having the negative charge. And with some velocity, with the radius r, this electron will be revolving around the nucleus. So to revolve the electron in the circular path, the necessity centripetal force should be provided. The necessity centripetal force will be provided by the electrostatic force of attraction between the electron and the nucleus. So here the necessity centripetal force is given by the electrostatic force of attraction between the electron and the nucleus. Okay. So the formula for the centripetal force is mv square by r. And for the electrostatic force of attraction between the electron and the nucleus is a 1 by 4 pi epsilon naught and electron and the nucleus. So according to electrostatic force of attraction, we are just taking the magnitude of the charges. The charges is having the positive and the negative charges, but the magnitude is only the electron. So divided by the distance between them. The distance between them is r. So square of the distance between them means r square. So mv square by r equal to 1 by 4 pi epsilon naught E into E by r square. So I'll write this equation for the v square. I will only keep the v square at this side and I will take everything to the another side. 1 by 4 pi epsilon naught E square by, this r will be cancelled. So then mr will be remaining. V square is equal to 1 by 4 pi epsilon naught E square by mr. I will take this as equation 1. Okay. So V square is equal to 1 by 4 pi epsilon naught E square by mr. And yes, leave it. And now tell me the formula for the kinetic energy. The formula for kinetic energy is what? Ek I will write as a kinetic energy as half mv square. Right? Half mv square. So I will write 1 by 2 as it is, m as it is, and I will substitute this value v square at the place of v square. So 1 by 4 pi epsilon naught E square by mr. So this m will be cancelled. So 1 by 4 into 2 is 8 pi epsilon naught E square by r will be remaining. I will take this as equation 2. Okay. So this is for the kinetic energy. Okay. And potential energy, I will write it as EP. So I will write the formula for the potential energy. Directly I will substitute it here. 1 by 4 pi epsilon naught E into E divided by R. So 1 by 4 pi epsilon naught, this is, it is having minus sign, I will take this minus sign side. So E square by R. So EP equal to minus 1 by 4 pi epsilon naught E square by R. I will take this as equation 3. So we got the value for Ek and Ep. So then what is the total E? That is Ek plus Ep. So substitute it together. 1 by 8 by epsilon naught E square I will write here into R minus E square by 4 pi epsilon naught R. So E equal to here E square pi epsilon naught R is common. E square pi epsilon naught R is common. 1 by 8 minus 1 by 4. So E square pi epsilon naught R, by taking the LCM 8 and 4 I will be getting 8. So 4 2s are 8 minus 1 E equal to E square by pi epsilon naught R. 2 minus 1 is 1. 1 by 8 will be remaining. So together I can write E equal to E square pi epsilon naught R and 8 here. So this is the formula for the total energy. E square minus E square by 8 by epsilon naught R. So, and we know the value of R by the radius of the nth orbit of an electron. That is epsilon naught n square h square by pi m E square. Substitute that value here. So, in the place of R we have to substitute minus E square by 8 by epsilon naught in the place of R into pi m E square by epsilon naught n square h square. Then I will be getting e to the power 4. This pi cancels. E to the power 4 m by minus e to the power 4 m by 8 epsilon naught square n square h square. This is the formula for the energy of a hydrogen atom. Minus e to the power 4 m by 8 epsilon naught square n square into h square. Okay, next from this, that is it is having the value E equal to minus epsilon naught square m by epsilon naught square n square h square, right? The 4 right, minus e to the power 4 m by epsilon naught square n square h square. This is a value for energy. Right, with this energy we are going to get the formula for the wavelength, wave number and the frequency. Yes, we know that when electron takes a transition from a higher energy to the lower energy state, then the photon will be liberated. That is E is equal to h nu. That is EI minus EF. Okay. So I can write h nu equal to, I know the value for E, that is e to the power 4 m by epsilon naught square n that is for higher energy, n2 square h square minus e to the power 4m by epsilon naught square n1 square h square. Okay, if I write it together, e to the power 4m epsilon naught square h square into minus 1 by n2 square minus of minus 1 by n1 square, that is for h nu, e to the power 4m epsilon naught square h square. I can write it as 1 by n1 square minus 1 by n2 square. So for a nu, I can write it as hc by lambda. Then I can write it as e to the power 4 m epsilon naught square h square 1 by n1 square minus 1 by n2 square. So and for 1 by lambda, that is nu bar, that is e to the power 4m by this hc will be coming down epsilon naught square h cube c 1 by n1 square minus 1 by n2 square. So again I can write it as in the place of e to the power 4m by epsilon naught square h cube by c as r 1 by n1 square minus 1 by n2 square. Here r is, I am taking it as a Rydberg constant, and it is having, I am taking it as a e to the power 4m by epsilon naught square h cube by c. It is having the value 1.097 into 10 to the power 7 meter inverse. This is the formula for the for the wavelength, frequency and the wave number of a hydrogen atom.